Good morning, everyone. I suggest we start, if that's okay. I am Leen Dont from the Humanitarian OpenStreetMap Team. I'm actually from the technology team, and there's another colleague of mine here as well, Emmy Marichal, and Miko from the Philippines is here as well. So we gave a high-level presentation this morning. Can I just know who attended that so I know how much? Okay. A few people. So I'm going to say in a nutshell what HOT is, and then go into detail in our fAIr, an open AI system mapping service that we are building at HOT. So HOT is an international nonprofit that's already there since 2010, that is focused basically on improving livelihoods through open map data by engaging communities, having them in the driving seat. So HOT is only an enabler. It's a catalyzer. It's not intended that we do the work. We basically want to enable communities, especially in low and middle income countries or people living in vulnerable areas, to be able to create map data and use that map data for their local challenges. So what does that actually mean, improving livelihoods? There is two main domains. Most people know HOT from disaster-related activations. When there's like earthquakes or cyclones or floodings, we often engage the remote mapping community, the OpenStreetMap community, to map areas that are affected. And we do that very often with like Maxar imagery, and we basically, so far we're able to engage 600,000 registered users on our platform to support activation, disaster activations. Using task managers is one of our tools, which HOT's used since a long time. What's done there is that people basically draw on satellite imagery, they draw the buildings, they draw like pre and post disaster situations so that this can be used by emergency responders to know where are people actually based, to know where the evacuation routes could be. Because in the countries where we work, very often the maps are, there's just no map data. Like try to look into Google for Togo and you won't see any data, and definitely not open data. So we're basically trying to build out, together with the communities on OpenStreetMap, to fill in the data gaps using tools like Tasking Manager, but also fAIr. Now that's one big domain where HOT is active, is in disaster management, which is both disaster risk prevention. It's basically working with local bodies to know, okay, if there's a disaster that's going to happen, where is the flooding going to be affected, which people first? That's one, and post-disaster activations. That's what HOT has been doing for a very long time. Since about 5-6 years, we really focused as well on development challenges, specifically urban development challenges, specifically in areas where the most vulnerable people live, which is often in informal settlements around big cities. And there, those people are definitely not on the map. So when something happens, nobody knows actually who is affected. Nobody knows where are the people that need the most support first. Nobody knows where are the shelters that we can place. So we basically are working with those communities to map those informal settlements as well. And then there's a completely different type of projects, like we map mangroves. In some countries, people ask us, hey, we want to map the before-after of mangrove deterioration. In some countries, they asked us, we want to map the fish ponds because we want to improve our agriculture outputs in the region. So HOT is the enabler. We don't decide what we map or whatever. We really work with the local communities to enable them to map and to use that map data for their challenge. So HOT provides the technology. HOT, together with everybody here, HOT provides training, peer-to-peer training, OMGuru training, what Miko explained a few days before. We actually have a peer-to-peer training where a community in one area can support another community in another area. And then we also do a lot of community engagement, where we, both remote engagement, we engage local mappers around the world for humanitarian mapping, but also underground. We really try, we have regional hubs in every, in every region that is connected to local governments, connected to local OSM communities, connected to local NGOs, and they then work together on the ground to do local field mapping. That's like, in a nutshell, what HOT is. So HOT has a dedicated tech team. We are based globally, and what we basically build is open source and free technology. Everything we do is on Git. So there's nothing that, that is not, let's say, public. As I mentioned, this is about HOT. Now, the core of, or why would we have tech? Like, ideally, there wouldn't be need of a tech team at HOT. Ideally, there would be technology out there that our communities can use directly. But there is a huge gap. There's still a huge gap between the technology that is out there, especially on the free and open source software, and what people can actually access and use in the countries where we work. There's barriers of language, like most of the tools are in English or like in French, some cases. There's barriers of just usability, like the barrier to entry of most of the tools is just way too high for the communities that we work with. There's barriers of offline, online. Many of the tools that are being built by many people need an online context. So there's all these specific all these reasons why very often the current technology that is out there is not sufficient for our communities to be able to map and use that map data. So our goal as a technology team is to try to lower the barrier to entry to that technology so that communities themselves can map and can use that map data. This morning we gave an overview of like all the technology, and today I want to deep dive in what we call fAIr. It's an AI-assisted mapping service. I am not an AI engineer. Normally this is a presentation from my colleague Kshitij Sharma, who couldn't make it. But I basically am part of the team, and I try to explain all our tools across on events and to our communities. So what is AI-assisted mapping service? As you know, HOT uses Tasking Manager today. Most people, is basically a way to edit OSM in an organized way. What we basically do is that we get a satellite imagery, we put a grid on that, and we assign, each people takes a piece of that grid and starts mapping that grid. Because if you're an individual and you think, oh, there's a hurricane in Jamaica, I'm never gonna start mapping Jamaica, this is gonna be a never-ending story. But if you know that there's all these other volunteers that are mapping another part of Jamaica, then you actually are motivated to say, okay, I'm gonna map this piece of Jamaica, and together we can map the whole Jamaica. So that's what so far, Tasking Manager has been a platform where people went to map areas. You basically draw polygons or lines, mainly polygons, but we also do road buildings and roads on a satellite. Now, this works, but it takes a lot of time, and we know that there's AI out there. I mean, this is not a new type of AI, this is a typical ML extraction. Like, this is not like the Gen AI, we're using the classical AI models from the past to see how can we use those open source models to extract buildings. We start with buildings, but also other objects from imagery, so that the community doesn't have to actually go and draw each and every building again, but can use predicted features from fAIr to then validate if that's good enough and then push that to OSM or to other open data layers. So we're really trying to see how can we leverage AI to make mapping more faster, but not only faster, also more easy. And I'll come to how we plan to do this. So what is the challenge? Right now, there is all these AI ML models that I assume many know, like object detection, where you can extract objects from imagery. But training those neural networks is very data intensive. We also need all the infrastructure, and it needs expert knowledge. Not everybody has that. And so we are looking to weigh on how we can actually enable the mapping community to reuse trained AI models and make those accessible for non-expert users. And how we do that, and I'll say where we are today and where we're going, because last year also I think Emmy gave a presentation on fAIr where we are today. Today we have a service in place which is called fAIr. If you go to fAIr.hotosm.org, where you can basically use that for mapping your area. Now, what does this do? It uses open source AI models. More specifically, right now we have been focusing on buildings, because that's like that's also what Tasking Manager is still doing most. Like, it's building mapping, it's base map mapping, is extracting buildings, but also we're experimenting with like roads, we're experimenting with rooftop materials to extract those objects from open source imagery. The imagery is one of the key bottlenecks today, because we need imagery that has a license where we can actually apply our open AI mapping. And that's not necessarily the case with Bing imagery, it's not necessarily the case with Maxar imagery. So we basically mainly use drone imagery that we are flying ourselves with the communities as the imagery layer on which we train then our models. So why do we actually need another AI-assisted mapping tool? I mean, there is Microsoft, there is Meta, there is Google, there's Ecopia, there's all these providers that provide you AI-assisted mapping data. So if you look, like there's Google ML Buildings for Africa, Microsoft has its own, but all these models are not open. We actually approached Google. We also got a no, like we can't make this model open. We approached Bing. So we're approaching also the big tech, but these models are not open, meaning that nobody can actually also see how they were trained. Nobody can see what is the bias in those models. The code is not open, the license isn't open. We're actually using open source models that are fully free and open, where so everything about it is open. You can, and I will show exactly what you can see in that. Also, there's all this, the bias in AI models, where you basically, if you train a model on detecting a certain type of building in New York, but then you train it on, that same model will not detect a building in, let's say, Chad, because a building looks very different. If you have a gray hut, a brown hut on a brown floor, on a brown sand floor, versus a building in, let's say, Auckland, that same model, if it's trained generically and not specifically for that area, will not necessarily detect good enough that building in Chad. So there's a bias in models. They're not sensitive to the local nature of the areas, especially not in the areas where we work, because most of the models were extensively trained on data from the global north. Plus, there is no human in the loop in those models. What we currently do, for example, with RepID, for the people that know RepID, that's Meta is providing a service that we can use their AI-assisted features to map in OSM. We basically get the features, we get the objects, but we don't know how were these objects created, based on which imagery, based on which models. People cannot train those models, people cannot give feedback to those models. So it's basically a one-way approach. So there's no human in the loop in the current approaches. And also, I mean, by not including people in the loop, they're not included in, they're like not agents of their own change. Like, if you just provide data here, go ahead and use that for your challenge. We realize that when you include people in the journey of the data that is then used to make decisions, people are much more inclined to follow the decisions. Especially in countries where the governments are like often not well trusted. So if you're part of the process of generating data, you're much more inclined to also be an active agent later on to do something with that data. So these are all the reasons why we are building an open AI-assisted mapping service. And what does it do today? So where we are today? Today we have basically two types of users. We have the mappers and we have the project managers. The mappers basically can use now OpenAI models to map, and I'll show how it works. And the mapping project managers are doing the more technical work. So there's still a need for technical expertise in setting up the project. There's still a need to know, okay, I'm going to choose this model and I'm going to localize it with this data to generate a localized model. But basically, once that's done, a mapper can reuse that localized model every time when he or she wants to update the area where he or she is living, can reuse that localized model to use the AI predicted features to update the map. So how does it work? As a mapper, so I'm starting first from like the majority of the current mappers, you can basically browse for a model. Imagine that you're based, I don't know, in Indonesia. You can see which models are already locally trained to see, okay, if there's already a model, I can actually reuse that model. We started about 2 years ago. We have about 300 models, 300 users and 160 models, I think. I'll come to that so far. And so basically people can say, okay, if this is a localized training model that's already trained, I'm going to see if that actually works on the data that I want to map. So basically you just choose a model and you say, I want to map with the AI model. You can actually see who created it. You can see all the details in the model files, like all the checkpoints, like all the data that you need to know about the model. If you want to know more as a project manager, you can, as a mapper, you can look into that. But if you just want to keep it simple, you just map with the AI model that you found. And then that basically returns objects. In this case, you see the buildings that are returned. And then you can basically give feedback to the model. You can say, yes, this building for me is good enough. This building, I will reject it. All the accepted features that are for you good enough, you can basically download. If you want to, you can upload that in, well, use that in JAWSM to update OSM. That's one way. Or you can just use the open data layer. So you can use your own data for any other purpose, not necessarily OSM. And if you reject it, you can actually leave a comment. To give an example, and some examples, we trained a model where there were blue rooftops. And at some point, they detected swimming pools as buildings. Then you basically know, okay, we have to adapt our model and adapt our training data set so that the training is more fit for, it won't detect pools as buildings anymore. So you can basically improve your model by giving feedback to the model. Now, for a project manager, it's a bit more complicated in the sense that you have to understand a bit of AI, but you don't have to be an AI expert. As a project manager, you basically can look for an AI model, a generic AI model. So today we're working with RAMP model and a YOLO model, which are two open source models that can, amongst others, detect buildings. And so as a project manager, you want to actually create a localized model. So you want to fine-tune the generic model with localized data and create a local model that works for your context. So if you use a generic model that was trained on the whole Earth, basically, on buildings, that will never perform good enough, at least based on the research that was done together with the Alan Turing Institute and together with Omdina, that will not perform good enough unless you, for example, localize it. If you have a model that is trained on the reality in Papua New Guinea, that's very different from the reality in Chad. So basically, if you fine-tune your model and you create a localized model that's more fit for your area, the results will be much better. Now, in parallel, we know that there's like models out there like Clay, like these generic models that are foundational models that use gigantic amount of data, that need a lot of storage, a lot of compute power, that intend to detect everything and are like intelligent and then don't need training data. What we're doing here is we're trying to use very low resource settings. Like we're trying not to utilize. We are right now at paying about $1,000 a month for our storage. And that's just because the way how this was set up, it's very low on compute power and very low on storage. So that's one of the benefits also of training a localized model. So once you basically know, okay, I wanna, for example, I want to use a YOLO model, I want to use a base model, and I want to create my own localized model for, in this case, a camp in the Rohingya. I think that's in Myanmar, Rohingya refugee camp, and I'm going to call this Rohingya refugee camp model. I'm going to use the imagery that I've available, ideally our drone imagery flown by the communities. And then I'm going to generate a training data set, and I'll come to that. You basically draw a limited amount of features to train the model that in this area a building looks like this. You define your area of interest, and then you can play with a few parameters of your training, and then you basically can submit your model so that anyone else can reuse that model if he or she wants to map areas that are similar to, in this case, the refugee camps. So training data, that's still manual mapping. Manual mapping can be done indeed in OSM, can also be done out of OSM, but so you basically need your imagery and you need labels. Labels is the training data. And from your training data, FAIR converts that to a raster, which we call a mask, which shows which is a building, which is not a building. And then it compares the imagery with the mask. And that's how a model basically can understand which pieces of my imagery are actually buildings based on the training data from my mask. So it requires much less manual mapping. If you would like to map the Rohingya camp fully by hand, it will take, depending on how many people you engage, a very long time. If you want to do it AI assisted with a model that's locally trained, you can actually reuse that model and train much faster. And, but you still need, of course, some training data before you can train the model. So there's still some manual mapping involved by our community members or by the project managers themselves. And so once you created your model, you can basically run those models and you can see how long did it take, who ran it, what's the size of your data sample, what's the accuracy. We are currently comparing the different models on like all the classical precision recall. Like we're really trying to see which ones are the best models, but it's really hard because you have to keep the same settings everywhere. So we're trying to see for example, YOLO seemed to be in theory better in predicting buildings than RAMP, but in reality, when we look at the outputs of the results, it's the opposite. So it's really hard to know which models perform now better, but you can actually check, if you would go to FAIR tool, you can check every single detail on how the model was trained, what were the checkpoints within the models. It remains a black box, but you have everything which can be available is made available through FAIR. So, and then you basically deploy the model and you make it available for mappers. In this case, again, anyone can basically now reuse that model and map in this case, the refugee camp much quicker. Now, what you again can do as a project manager, if people then use your model and they give you feedback, actually no, this building is in the middle of the road, this is not the building, this is wrong. So people give feedback, the mappers give feedback to the project manager, actually no, this is not a good output. The project manager can optimize the training data set on which the model was trained. And we're now talking to the ITS University of Twente to see to what extent they're doing analysis on where to optimize your training data sets, where should you best go and generate training data for your models. Because also that's a whole new science, well, maybe not new, but new to us at least. So where we are today, as I mentioned, about 136 models, around 300 registered users. We have the whole interface is in place, the whole process works. So you can create models, you can run predictions, you can generate feedback, and you can actually use that data. We have used this in Freetown recently, where we mapped large parts of Freetown using AI-assisted mapping. There's a big, there's still, we still aren't there yet in the sense that the models can easily detect buildings in more rural areas, especially square buildings, easy buildings. But as soon as you go to areas which are a bit more rural, it gets very complicated. Especially we have been testing areas like Freetown, which are really dense areas. It's still hard to get there an extraction of buildings today. So that's, and now we're experimenting maybe if we add 3D imagery where you can actually look also a bit underneath, then you can see which is you can have more information to extract which is a building and which is a separate building, because now it often returns a group of buildings. Now this is where we are today. We have ambitious plans, and we have also the possibility to do that, to make them possible. We basically realized a few things, that we have been implementing 2 models. In the meantime, some models are maintained, some models are not maintained. There's all these models out there. There's all these research institutes. There's a lot of startups. There's a lot of spin-offs from universities that are also building open source models. And we were like, hey, how can we ever keep up with all those models that are being open source? So what we're working on is, instead of us implementing models, turning FAIr into a platform for GeoAI models, where anyone can plug in their GeoAI models using what we call stack MLM standards, so standards that can enable anyone to plug in their open source GeoAI model into FAIr. So for example, the University of Heidelberg has an open source model on detecting road surface. They want to make that accessible to the open mapping community. What we can do is we can plug in their model into FAIr and make that accessible to the open mapping community without us being the bottleneck. We are not implementing the models. We reuse the models. The universities or the organizations that have those models, the model developers, can actually plug in their models into the platform, and then FAIr makes those accessible to the open mapping community through the same platform. That's one, and this is actually, this is the concept, and we're actually working on this. This is currently being done by our Kshitish himself together with a collaboration with MSF. Where what will happen is that you will have a new user, a developer. I had this very cool model, and I want to make that available to the humanitarian mapping community. I can plug in my model into a catalog within FAIr, and as a mapping community, I can, just like before, select my model. I want to map trees. I'm going to select which model is best to map trees, and I'm going to train it on my local area, and then I can make that localized model available. So we really want to make it kind of a marketplace instead of us trying to implement each and every model. And the other, let's say, very new and also very active project that we are implementing now is to see how can we collaborate with MapSwipe. I don't know to what extent people know MapSwipe. MapSwipe is also a mapping application where you basically can just swipe left or right to confirm, is this a building or not? Is there a building in space or was this before and after situation? So they have all these projects currently on MapSwipe. It's a mobile application that's heavily used in the open mapping communities. Missing Maps is one of the founders. Hot is a participant of that initiative as well. And it's currently mainly used as a pre-processing step for Tasking Manager. As I mentioned, Tasking Manager is a tool where people manually draw today buildings. But in some areas, like in Congo, if you have to start scrolling all over the place, where is there a building, it can take a very long time. So what MapSwipe does, MapSwipe gives you a pre-processing step where people swipe left or right, yes, I see buildings on this image or not. If you see buildings, you basically say, yes, I see a building, and that tile goes to Tasking Manager, and then that actually gets mapped. So there's like a pre-processing step before going into Tasking Manager. This is heavily used because it's very simple. Anyone that has a phone, basically, can swipe left or right and contribute to the open mapping community. And so because we think FAIr is still today too complicated. People still need to map those boundaries. They still need to create data. How can we lower that barrier to entry for our communities to train and to validate AI models? So we are now working together with the MapSwipe developers to basically enable MapSwipe to connect with fAIr, where people will, just by swiping, be able to validate the outputs of the models. And this is an example. People won't know which one is the AI predicted one and which one is the OSM one. We will have different colors, and then they will have to say which building should be on OSM, the red one or the blue one. They don't know which one is OSM. And then once they confirm actually it's the red one, we can delete this one and enter that one, depending on who was right or wrong. Sometimes the building is completely missing. People just have to confirm there's a building missing, and based on the picture that you have on MapSwipe, you can say, for me, this building is good enough. I'm going to confirm, and I'm going to push that to OSM or to any other open data layer. That's the idea. So there is actually a human in the loop at the validation and at the training of those models. Right now, we are mainly looking into segmentation models, so they basically extract images, objects from imagery. But we're also experimenting with classification models where just by swiping left or right, like, yes, this is rooftop farming. No, this is not rooftop farming. Just by doing that, you can already pre-select where to go mapping for rooftop farming. So by combining the strengths of fAIr, GeoAI models, and the strength of a crowdsourced mapping application, we really try to see to what extent can we include people themselves in training open AI models. Now, this is a piece of the puzzle. As I mentioned this morning as well, we have at HOT, we're building an end-to-end mapping suite in which we reuse as much as possible the existing technology. When we see a gap, we try to fill that gap. And so fAIr is a part of this, I'd say, process where, first of all, we are building drone technology ourselves. I explained that this morning. We have remote mapping with Task Manager. We're trying to make that more AI-assisted. And we hope to get to a situation where there'll be more AI-assisted than manual mapping. Again, we're not there yet. Today, still, depending on the use case, because sometimes you do need the perfect building. Sometimes you really need the perfect outline. It needs to be squared. The OSM community, the quality requirements are very high. People don't want buildings that are just more or less a building. They really want the exact building. But for some use cases, if you're post-disaster, sometimes it's enough to know how many buildings are there. Like, it doesn't need to be the exact, so depending on the use case already, AI-assisted mapping is being applied. Then we are building field tools. I think my colleague will explain more of that in the next session. We have tools that enable you to download all that data from OSM, like export tool, and we have our raw data API, and we have tools that we started working on, which is UMAP, hot OSM UMAP, where people can easily visualize all that data. So this is just to say that the AI-assisted mapping tool that we're building is part of a larger ecosystem that enables communities to generate their own drone tech, low cost, low-weight drones that and drone technology that we work together with the ODM team, use open source map editing tools for object detection, add field knowledge to that, and then use that map data themselves. And I think that's my last slide. Very important, I want to specifically say that these are star colleagues, Oman, Najar, Kshitij, Sharma, who are the brain behind all this. Oman is our project lead on fAIr. Kshitij is one of the AI engineers. We are hiring a new AI engineer on to accelerate this work. I'm part of the team as well, and if you want to see all the source code, everything is on Git. And feel free to check out fAIr if you want to try it out. That was my last slide. Yes.
So, from our experience with machine learning, it's often important to know for a particular model where the training data was captured, so that if you want to improve the model, but still be localized, you want to obviously have new training data that is of an area that the model hasn't seen yet or hasn't been trained on yet. When you go into the model system that you have there where it displays models, are you able to see where that model was trained? You are.
So in the case of our own AI models, yes, you can trace back. In the case of those generic models that we basically use that are open, we don't know how these were trained. So we start from a generic model, but then we train them with the local training data that we have created ourselves. You can see how big was the sample. You can look into all details on like, how did we localize that generic model? that is possible. But we don't know how this generic model was built. Any other questions? Feel free to reach out at any point in time. I'm going to hand over to Emmy for the next presentation. But thanks a lot. Thank you.